Hello everyone, today we are going to discuss about mode characteristics of Reflex Klystron, and this one is the corresponding block diagram. We have Klystron power supply, Klystron mount, isolator, frequency meter, detector mount, VSWR meter and CRO, and this is the experimental setup which represents the microwave test bed. And here we have a Klystron power supply. So this Klystron power supply consisting of beam voltage, reflector voltage and respective modulation knobs. And here we are going to initially set in the AM mode, and we are going to put this knob into beam mode, and here we are going to put beam voltage in fully anti-clockwise and reflector voltage fully clockwise. Now we are going to see the Klystron mount. So this is the Klystron mount, and this one is the isolator. It allows the signal only in one direction, and this is the variable attenuator, and this one is the frequency meter, and this is slaughter line section, and this is detector mount. The output of detector mount is given to directly CRO. Now we are going to discuss about the experiment. Initially we are going to adjust the reflector voltage. So by adjusting reflector voltage, we can vary the value. By varying the value, here we can see that the waveform is going to vary, and this is the 0 level, and next mode gets increasing, and again it goes to 0, and again it goes to next mode maximum value, and this is the minimum value. Respective voltage is going to vary here. The readings are taken and it is tabulated, and the respective graph will be drawn. And here we are going to draw the graph. So this is the model graph, and based on this we are going to draw the graph, and from this we can analyze the Reflex Klystron characteristics. Thank you. Hello everyone, today we are going to discuss about the measurement of VSWR experiment, and this is the block diagram, the same diagram for all the experiments: Klystron mount power supply, Klystron mount isolator, frequency meter and starter line section, a movable slot, CRO and VSWR meter. Here we have a Klystron power supply, and that one is the experimental setup. Already we have discussed experimental setup, and the output of detector mount is directly connected to the VSWR meter. Here we have a different kinds of VSWR meter: normal, expanded and decibel. And here we are going to select expanded mode, normal mode, -3 dB mode, and here we are going to select the range of the VSWR signal. And if I am going to adjust the reflectometer, Klystron power supply means here we have variation in the VSWR meter. By using the required voltage, we can find out the respective VSWR value for the corresponding waveform. Thank you. Hello everyone, today we are going to discuss about the measurement of frequency wavelength for a microwave oscillator, and this one is the experimental setup, respective block diagram, and this one is the Klystron power supply, and here we have an experimental setup, and here we are going to connect the CRO probe in the movable starter line section. Here we are going to connect the CRO probe in the movable starter line section. Now the respective square waveform will be observed in the CRO. What we are going to do here, we are going to move the starter line section and to find out the maxima minima of the waveform. By adjusting this starter line section, we have a variation in the amplitude of the square waveform. The readings will be taken and it will be tabulated. So this is the distance method: maximum value, minimum value, D1 and D2. So by using the formula, we are going to find out the respective frequency and wavelength value. And here you can see this is the frequency of oscillation that will be found out by using rotating the frequency meter. By rotating the frequency meter, the amplitude of the waveform is going to decrease. At one point it is going to reach the 0 value. So this is the direct frequency meter reading. So this frequency represents this value, and here we can find out the two distance value D1 and D2 by using this starter instruction. We can measure the D1 D2 value, and here we are going to find out the lambda naught value. Then we can find out the lambda g value, which is wavelength, and we can find out the wavelength value, and we can find out the frequency value by using the respective formula. Thank you. Hello everyone, today we are going to discuss about characteristics of Gunn oscillator. This is the corresponding block diagram, which consists of Gunn power supply, Gunn oscillator, pin modulator, isolator, slot in section, return mode, and VSWR meter. And this one is the Exp.No.01 setup. This is Gunn power supply, so which gives the generates the microwave signal for a Gunn diode. And here we have a voltage, and here we have a current. By adjusting this Gunn bias voltage, the voltage value will be varied. The respective current value is also going to vary here. Here Gunn output is connected to the Gunn oscillator, and pin output is connected to the pin modulator, and the respective reading will be taken for a Gunn bias voltage. By adjusting Gunn bias voltage, here we have increment in the current. After certain value, the current value gets decreases. This is the characteristics graph for a Gunn diode. From the tabulation, we are going to draw the graph. From this graph, we are going to find out the respective threshold voltage. Thank you.